Today we are discussing about interhalogens. So, it is a part of 7th year group elements, they are below P block elements. The interhalogens, the definition the one halogen combined with other halogen to form several compounds, they are called interhalogens, right. The interhalogens are basically 4 types: AX type, AX3, AX5, AX7. And the examples AX both are halogens. The A role is big atom and X role is small atom. The both are halogens. For example, you take AX, for example, Cl act as a role and F acting as a X role. So, ClF is a type, first type of interhalogen. Suppose AX7, the A is a big atom like this, iodine acting as a and F and chlorine acting as a X role, therefore, AX7, IF7. So, they are all the examples BRF5 and BRF3 like this, they are all different interhalogens. Now, the properties, just the properties, out of the properties, the most important property is hydrolysis property. On reaction with water, the interhalogens are produced 2 acids, very important this one example. Suppose the one interhalogen interact with water gives 2 acids, one is hydro acid and second one is oxy acids. Suppose you take ICl, the both halogens are iodine and chlorine here, the chlorine is a more electronegative, iodine is a less electronegative. More electronegative halogen gives hydro acid, less electronegative halogen gives oxy acids, right. For example, ICl when dissolved in water, they gives HCl and HOI. The HCl is called hydro, HOI is called oxy acids. You see the next examples also BRF5 and IF7 also same way. Now, come to the important one is structure of interhalogens. Already we seen the 4 interhalogens are there. You take first one AX model. The best example for AX type of all interhalogens, one is ICl, IBr, IF, etc. You take first ICl. In ICl, the iodine acting as a central atom. The iodine ground state electron configuration is 5s2, 5p5, right. In ground state, so one p orbital having 1 electron, the remaining p orbital and s orbital filled with 2 electrons, but here the 5d orbital or vacant d orbitals there. It is the ground state, alright. Around iodine only 1 chlorine is participating here. So, that is why the 1 chlorine atom, right, the chlorine atom interact with this unpaired electron, single electron of p orbitals, right. The remaining does not change here. So, right, say the 1 s orbital and 3 p orbital combine together to form sp3 hybrid orbitals. Okay. In sp3 hybrid orbitals, 3 orbitals filled with 2 electrons like s orbital and 2 p orbital with 2 electrons. The unpaired electron p orbital associated with chlorine atom gives a single bond, sigma bond, okay, right. So, the 4 this is the sp3 hybridization, right. Now, the structure geometry is, you see the AX model of geometry, it is a linear geometry, the number of lone pairs are 3 and number of sigma bond 1, 3 plus 1 4, sp3 hybridization, the geometry is linear geometry, right? This is the first one. Now come to AX3 type of interhalogens. In AX3, the best example, IF3 and BRF3 and CLF3, etc. You take ICL3 or IF3. In ICL3, the iodine ground state electron configuration, just you see 5s2 and pi p, right, 5 and 5d 0. So, naturally in ground state only one chlorine accommodated in pz orbitals, but we have accommodated another 3 halogens also, AX3 mod another 2. So, that is why the iodine going to excited state, first excited state and second excited state. After second excited state, the central atom of halogen create the vacancies of positions like this. So, what happened? So, for total after second excited state, the px electron and py electron going to d orbitals, right. So, for example, you take first excited state, the py electron going to moving towards pz d orbitals. That is why the naturally two lone pair s orbital containing 2 electrons and px containing 2 electrons, paired electrons, but the unpaired electrons, one is py, pz and 1 d orbitals. So, in this condition, the iodine, central iodine, 1 s orbital and 3 p orbital and 1 d orbital combine together to form sp3d hybrid orbitals. In sp3 hybrid orbitals, out of the 5, 2 orbitals filled with naturally 2 electrons, the remaining 3 orbitals containing single electrons. The single unpaired 3 orbitals, hybrid orbitals associate with, so overlap with the p orbitals of another 3 halogens atoms, right. So, now the sp3d molecules are formed here. So, the structural information about the AX3 type, the hybridization, the number of lone pairs 2 and number of sigma bonds are 3 and 2 plus 3 5. The 5 means the hybridization is sp3d and geometry is, this is the geometry, right. The geometry is sp3d. The next molecule is AX5 type. Here AX type of best example IF5 and BRF5, etc. So, you take IF5, the molecule, the iodine is a central atom, the same electron configuration, ground state configuration. According to ground state configuration, we have to provide only one another halogen only bonding, but here the 4 extra 5 halogens are associated with the central atom. So, in the situation, the central iodine going to excited state, first excited state and second excited state. After second excited state, the central iodine create the 5 unpaired electrons and 1 pairing of orbitals. So, the total 1 s orbital and 3 p orbital and 2 d orbital, the total 5 combined together to form sp3d2 hybrid orbitals. So, in sp3d2 hybrid orbitals, only one orbital containing 2 electrons, the remaining 5 orbitals containing single electron. The single unpaired 5 sp3d2 hybrid orbitals overlapping with another 5 halogen atoms. So, gives AX5 molecule. So, like this is the example AX5 models. You see ground state and second excited state, after overlapping we are getting this molecule. So, now see the structural information, the information around the central halogen. The number of sigma bonds are 5, the number of lone pair 1, 5 plus 1 6. So, the hybridization sp3d2 and geometry is square pyramidal because of one lone pair present on central iodine. So, this is the information about AX5 type of interhalogens, right. Here sp3d2 and geometry is square pyramidal. Now go to the last one is AX7 type of interhalogens. So here also best example is IF7, the central iodine ground state, and according to ground state we have to accommodate only one extra halogen, but here 7 halogens are participating in the formation of this molecule. In the situation, the central iodine going to third excited state. So third excited means s electron moving towards d orbital, and px, py, the pairing electrons also moving towards d orbitals. Ultimately, the total 7 unpaired electrons are formed here. The 7 unpaired electrons, 1 s orbital, 3 p orbital, 3 d orbital, the total 7 orbitals are combined together to form sp3d3 hybrid orbitals. The sp3d3 7 orbitals are having single electron, right? The single 7 orbitals are overlapping with 7 other halogen atoms, gives AX7 molecule or IF7 molecule, right? So therefore the information about the structure. So the number of sigmas are 7, the number of lone pairs are 0, total 7. 7 means the hybridization sp3d3, right, and geometry pentagonal bipyramidal. So this is the information about AX7 model or AX7. So now see, these are the structures of interhalogens. AX type linear, and this is T shape sp3d hybridization AX3 model, and AX5 type and square pyramidal, and this one is AX7 type, the last one, and pentagonal bipyramidal geometry, right. So these are the shape of interhalogens molecules, and these are the bond angles and bond length between the central atom and terminal atoms like this. And now the uses of interhalogen compounds, right. We use interhalogen compounds are non-aqueous solvents. This is the first use. And second one, we use these compounds as a catalyst of number of reactions. So in chemical reactions, the interhalogen also we have to using as a catalyst, right. And we use these compounds, the fluorinating compounds. So when we are providing, we want the more fluorines, we have to using these compounds also. These compounds are we have to utilize using fluorinating compounds also. So, okay. So there are all the uses of interhalogens. Then we go to the next one. After interhalogens, we go to the next one, polyhalides. Poly means many, okay. Polyhalides. When the halide ion combined with the halogen molecules or interhalogen, the univalent ions are obtained. These are known as polyhalide ion, and the compounds of these are known as polyhalides, right. So the polyhalide ions are examples are IBr2 minus and ICl2 minus and ClBr2 minus and BrCl2 minus. So these are all polyhalide ions. And next one, polyhalide compounds, okay. The first one is anion, the next one is stable molecule KiCl4 and NaIBr4, NH4IBr2 and Ki3 potassium triiodide. So in Ki3 the halide anion is I3 minus, right. So these are all examples of polyhalide ion and polyhalide compounds. Now you see, we discuss about the structures of polyhalides. You take ICl2 minus, here the central atom is iodine, okay. The iodine interact with 2 Cl's chlorine atoms, right. The central atom iodine having 7 valence electrons, but 1 electron gained from outside. So the 7 plus 1, 8 electrons are accommodated around the iodine. Out of the 8 electrons, only 2 electrons formation of bonding with the 2 terminal chlorines, right. Therefore, around central atom, right, out of the 8, 2 electrons are participating with the 2 chlorine atoms, the remaining, right, 3 pairs of lone pairs are present here. So, 3 lone pairs and 2 sigma bonds around chlorine, iodine, 2 sigma, 3 lone pair, total 5. So, 5 means sp3d geometry. So, all the ICl2 minus shows sp3d hybridization and geometry is linear. The same structure, similar structure, I3 minus also same. ICl2 minus and I3 minus both are shows same geometry, that is linear geometry, and both are exhibit same hybridization, that is called sp3d, because of the central atom iodine having same 3 lone pairs and 2 sigma bonds are present. So, this is the structure of polyhalide ion. And now go to the next one, pseudo halogens. Pseudo means it is not a real halogens, but they are exhibiting, they are functioning the same similar properties with halogens. The type of compounds are called pseudo halogens. వీటి మిథ్యా హాలోజన్లు అంటారు. అంటే ఇవి నిజమైన హాలోజన్లు కావు, కానీ వీటి యొక్క ప్రాపర్టీస్, వీటి బిహేవియర్ హాలోజన్స్ ప్రాపర్టీస్ లాగానే ఉంటాయి కనుక వీటిని ఏమంటారు, సూడో హాలోజన్స్ ఆర్ మిథ్యా హాలోజన్స్ అంటారు. ద రైట్ డెఫినేషన్ ఈజ్ ఏ ఫ్యూ మాలిక్యూల్స్ హ్యావ్ ప్రాపర్టీస్ similar to the halogens are called pseudo halogens. Best examples, cyanide ion Cn minus is not a real halogen, the property is similar with the halogen. And thiocyanate ion SCN minus and cyanate ion OCN minus and isocyanate ion ONC minus and azide ion N3 minus. These are all the few examples for pseudo halogens. The preparation of a pseudo halogen. So, first of all you take a molecular state, the Cn minus, dimeric state Cn2 minus. So, the dry cyanogen is obtained by heating of a mixture of mercurous cyanide and mercuric chloride. We are getting mercurous and mercuric chloride, we are getting Cn molecule, right, Cn taken twice. It is a colorless and toxic gas with pungent odor. The 2 cyano groups are bonded together at their carbon atoms. So, the importance, the uses of cyanogen molecule is, the most important is it is used intermediate in the production of many fertilizers. It is also used as a stabilizers in the production of nitrocellulose. Okay, it is a intermediate compound. And the next one is the similarities between halogen and pseudo halogens. Just now I told you it is not a halogen, but the functions are similar with halogens. So, the similarities, so like halogens, the best one is they are volatile gases. So, halogens మాదిరిగానే pseudo halogens కూడా volatile, easily evaporated. And second property, capable of forming hydroacids. So, the halogen, any halogen interact with water gives hydroacids. Same way the pseudo halogens when interact with water gives hydroacids, right, it is a similar property. Like halogens, the pseudo halogens also form with silver, lead, mercury precipitates. Okay, like suppose you take chlorine, when interact with the silver gives AgCl precipitate. The same way the cyanogen Cn minus in pseudo halogen when interact with the silver AgCN precipitate. So, not only silver, the lead and mercury also interact with the halogens and pseudo halogens gives their corresponding precipitates. And another, like halogens, the pseudo halogens also form inter pseudo halogens. Okay na? Inter halogens అని చెప్పాను, ఒక హాలోజన్ ఇంకో హాలోజన్తో రియాక్ట్ అయితే గివ్స్ ఇంటర్ ఫామ్ అవుతాయి అన్నాను. సేమ్ వే one pseudo halogen interact with other pseudo halogens, they give inter pseudo halogens. It is similar property with halogen. And the same like halogens, the pseudo halogens also to form poly pseudo halide ions, right? Poly pseudo halogens also form chestayi. So these are all the similar properties with halogens. And another one, react with alkali, produce similar compounds. And the pseudo halogens form complex and act as a bridge ligands. Okay, na? And the pseudo halogens react with alkene to give addition compounds. So these are all the similar properties of halogens. And the next one, the similar properties. Now the another one is we discuss about some few questions about the multiple choice questions from 7th year group elements. Suppose one question in exam entrance point of view, the number of lone pairs are present on iodine in IF. Just now I told you IF is a one of the interhalogen, the first type of interhalogen AX type. In iodine, the iodine central atom, the iodine around iodine, the 7 valence electrons are present. Out of the 7, 1 electron interact with 1 fluorine, they give 1 sigma bond. So now the remaining 3 lone pairs, 1 sigma bonds are present around the iodine. So now they are asking the number of lone pairs are present on iodine. So how many lone pairs? The right answer is 3. So 3 lone pairs, 1 sigma bond. So this is the right answer. A is the right answer. Right? Same way, which of the following interhalogen does not exist? It is also a beautiful question for entrance point of view. Now you see the options are given CLF, CLF2 and BRF3 and ICL3. You know our interhalogens are 4 types: AX, AX3, AX5, AX7. Okay, out of the 4 halogens here the CLF2 can't exist. So we have only AX, AX3, AX5, AX7, but AX2 not exist. Therefore, the right answer is B. Right. The next third one is the another question, very important question. The ICL on hydrolysis produce. Just now I told you any interhalogen when dissolved in water, they produce 2 types of acids. One is hydroacid, the second one is oxyacid. If you take interhalogen, the more electronegative halogen gives hydro and a less electronegative halogen gives oxyacids. So now our question is ICL. In ICL, chlorine is a more electronegative atom. This chlorine when interact with water gives HCl, and iodine is a less electronegative atom. This iodine interact with water gives HOI. So therefore, the right option is HCl, HOI. The B is the right answer, right? And the next one, the structure of ICl2 minus. The structure of ICl2 minus. The central atom iodine, around iodine, the actually 7 valence electrons are present. 1 electron gained from outside, now become 8 electrons are there. The out of the 8 electrons, 2 electrons participating bonding with the 2 chlorine atoms. Therefore, the remaining 3 lone pairs are present around the central atom of iodine, 2 sigma bonds, 3 lone pairs, so total 5. The 5 means sp3 dehybridization, the geometry is T shape. Okay. So this is the structure. And now the next one, hybridization of ICl3. ICl3 hybridization, right? The ICl, who is the central atom here? Iodine is a central atom. It is a best example for AX3 type of interhalogens. So AX3, the central atom iodine, 7 valence electrons. Out of the 7, 3 electrons participating with the 3 chlorine molecule. Those 3 sigma bonds are formed here. 3 sigma, 2 lone pairs. Total 5. 5 means sp3d hybridization. Therefore, the right answer is B. Now go to the next question. The example for pseudo halogens. Just now I told you about the pseudo halogens. The examples N3 minus, Cn minus, SCn minus. So all are belongs to pseudo halogens. Therefore, the right answer is D, all the above. Now, the last one, which among the following is most reactive? It is an excellent question. We are expecting in a competitive examination point of view, which of the among the following is most reactive? You see, the option A is iodine, option B is ICl, option C Cl2, option B is bromine, right. So, you see iodine and Cl2 and Br2 purely halogens, but the B is ICl is interhalogen. You remember, the interhalogens are more reactive than normal halogens, right, because of here two different halogens combined here. Therefore, the normal halogen molecules are less reactive than interhalogens. Therefore, the right answer is B is the right answer, right. So, this is the interhalogens information questions and pseudo halogens and everything. So, now today we discussed about the 7th year group elements properties. After 7th year group elements, we discussed about the structures of interhalogens, the interhalogens classification. We have discussed about the 4 interhalogens, AX type, AX3, AX5, AX7 type with examples and structural information also completed. So, AX model examples with structure and AX3 examples with structures clear. And after interhalogens, the uses of interhalogens we studied, and then the next one, polyhalide ions, polyhalides. So, what is the polyhalides? The examples of polyhalides and structures of polyhalides also we studied. Okay, after polyhalides, we discussed about the pseudo halogens. So, the definition of pseudo halogens, examples of pseudo halogens and similar properties of pseudo halogens. So, like halogens. So, the pseudo halogens examples everything complete discussed. And the next one, the questions. Suppose in examination point of view, explain interhalogens, define interhalogen, what is interhalogens, how many types, explain with geometry. This is one type of questions. And what is pseudo halogens, give suitable examples and write the similar properties with the halogens, this type of questions. What is polyhalides, give examples and explain I3 minus structure, explain ICl2 minus structure. So, these are the few questions we are expecting coming examination in theory examination point of view, as well as just now in entrance point of view multiple choice questions also we discussed. Okay. So, this is the information about 7th year group elements, halogens. Out of the P block elements, the 7th year group elements are the very active group and very active elements are present here. So, it is a very important, and because of in this group all elements are interacting very attracting easily involved with all chemical reactions, very active elements are there. That is why the halogens are highly electronegative elements, highly electro affinity group elements are present here. That is why one of the element here, the fluorine is a generally we called super halogen. So, that is why the 7th group elements, the properties and structures are very, very important in examination point of view. Okay. So, the further class we are going to the next class, we are discussing the next P block elements. Right. Thank you.